Assalamualaikum and a very good day. I greet to the lecturers. Today, my group will be presenting for the subject of additive manufacturing. Our product is prosthetic hand. I'm ADRIANA along with my friends ALIF, MOHAMMAD, ZAIRUL and HAKIMI will be presenting about the product. Introduction. Hand is very important for physical and social interactions, so the loss of hand can be devastating as it affects the capacity of work, social and everyday activities. So prosthetic hand is actually an advanced technology made to help people who suffer from the loss of their hands. So the important features of the prosthetic hand is it must be lightweight, high strength, aesthetic and optimal to use. So the evolvement of the prosthetic hands from using the traditional material is popular since the additive manufacturing is known. The team will develop a prosthetic hand design that uses an AM system. So this project is done to understand the additive manufacturing technologies and material better and able to synthesize its economic and environmental impact of the product that is designed. Literature review. Cordella et al. 2016 stated that the large number of degrees of freedom for hands play an important role by thumbs in a position that enable the human to achieve sophisticated movement from the power to precision tasks. For the material, the Song et al. 2017 stated that thermoplastic such as polylactic acid and acrylonitrile butadiene styrene also used to make prosthetic hand, as it is relatively stiff with the young modulus suitable for the prototyping. Radel 2019 mentioned that materials such as ABS plastic or bridge nylon are used for 3D printed prosthetic. This is actually to improve the durability and strength after the 3D printers are becoming compatible with other materials such as lightweight titanium. So for the process, King et al. 2015 stated that mostly 3D printing is used in making the prosthetic hands. However, when the volume of the production increases, it used to combine manufacturing such that 3D printing and injection molding to make the prosthetic hands.
Assalamualaikum. My name is Muhammad Alif A.AZIZ. So today I would like to present about methodology. So for this project, we use the reverse engineering method. So as we know, the reverse engineering method is a design process by using a physical part as a starting point for analyzing or creating a product. So the value must be the valuable way to exact the original product design. So by analyzing the whole product of prosthetic hand, we will improve the design structure. So for the product description, the design process by using a physical part for analyzing, then analyze the whole product of prosthetic hand. So for the mechanism of product, the mechanism use a different length and level in open or closed mechanism with a suitable joint. So the whole design was limited to the variety of basic move such as 2-finger grip or 3. So for the example of mechanism is finger linkage design 1. So this is the function of prosthetic hand by part. So in the prosthetic, we got the socket part, endoskeletal prosthetic arm part, endoskeletal prosthetic arm part 2. So this is the product structure, which means the three main part is prosthetic hand. In the finger, there are 3 parts below it, which is proximal phalanx, distal phalanx, and middle phalanx.
Bismillahirrahmanirrahim. My name is Muhammad bin Abdul MUTALIB. I will continue the methodology part presentation, which is the bill of material of the old product, which is prosthetic arm by using process of conventional process. So for the part of pylon arm, outer arm, keel, flex pad, bolt and nut, commonly used material of high density polyethylene, polyurethane, aluminum alloy, and also stainless steel included during the manufacturing process. So the manufacturing process involves such as injection molding, post-processing, post-machining, injection molding, die casting, and also ultrasonic welding during the process of making the old product of prosthetic arm. So for the weakness of the old product, which is the weight is much larger and the size is much bigger because of the uses of a material such as stainless steel, which is stainless steel is much heavyweight, so it's not suitable for a person to use as a prosthetic hand. So in terms of hygiene, it's also probability on getting skin problem or bleeding during the using of prosthetic arm. And the part-time consuming to fabricate is much longer because the complexity of making the each part by doing the process using conventional traditional process manufacturing. So in terms of cost, for the additive manufacturing is much more higher cost than by using the traditional manufacturing. Even though the cost of additive manufacturing is higher, but in terms of quality and in terms of sustainability or hygiene, additive manufacturing is much more benefit to the users. This is the STL file of drawing by using SolidWorks of the proposed new design. This is the proposed new design: main arm socket, thumb finger joint, and palm of the prosthetic arm. This is the step on making, which is design, over to STL file, and then printing to the 3D printed, and then we assemble. This is the bill of material of the new proposed design. For the new proposed design, material used such as ABS plastic, PLA plastic, nylon, and the manufacturing process is basically 3D printing, fused deposition modeling, and that's all for the bill of material of the proposed new design. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I am HAKIMI, ZAFRIDIN. Today I will discuss about our project, which is prosthetic hand. This is comparison between old design and new design. The old design they use the material which is high density polyethylene polyuterine 6061 aluminum alloy, EVA, and the stainless steel. For the new design, we choose the two materials, which is ABS plastic and the PLA plastic. And we use the 3D printing FDM process. Percentage part reduction. We maintain the component of hand prosthetic, but we compare it in terms of manufacturing process and material. PLA material, we use it into the new design, which is biodegradable, and it is made from a renewable energy source and not produced toxic smoke when it melt. Compared to the old design, they use the injection molding, where may cause corrosion on the mold, and this product will not hygiene and can affect the users. Also, the new design use ABS material. This ABS plastic very popular for many applications. Physical properties for ABS, which is impact resistance, tensile strength, and stiffness. ABS plastic also used for pylon arm and outer arm prosthetic hand, because this part emphasize strength, and most importantly is lighter than the material used in the old design. Usability improvement with reduction, because we use the PLA plastic and ABS plastic, which is lighter than the old design. No maintenance need for mold cleaning. We can reduce weights by focusing on small amount of manufacturing process by using the 3D printing and machine capabilities, where this complex design on the prosthetic hand, such as a socket, thumb, and fingers, that give 3D printing advantages, better design development compared to old design. The economical and mechanical justification and analysis, we compare this two process, which is 3D printing and the injection molding. For the weld structure, lower workers needed for the 3D printing, and they use the lightweight material, and cost of the machine not as expensive as injection molding. For the injection molding, a lot manpower is needed. Material used are heavy and the cost of the machine is expensive. Next, the ill structure. For the 3D printing, they are user-friendly machine, less inventory cost, and easy to see the defect. For the injection molding, machines that use mold and require maintenance. High inventory cost because large stock need to store in the one time. Difficult to see the defect in the large production. The last one is design structure and materials such as PLA and ABS, which has sustainably higher transition temperature is and very suitable to use for build prosthetic hand with the durability and to lift something effectively. A 3D printing process is important to make a comfort, efficient and useful prosthetic hand by complex design that have made by designer.
Assalamualaikum, my name is HAFIZ bin Muhammad ZAMRI. I will talk about conclusion. In conclusion, software to slice CAD model for layer by layer construction has paved the way for AM, additive manufacturing, to thrive compared with the same material process using a conventional method. Material processes by AM will also have very distinct. With the help of CNC machine, the engineering design assisted by CAD CAE CAM technique enable rapid product creation. Reverse engineering allow 3D scanning technique to produce surface model for certain production processes. This method will allow part for prosthetic hand and equipment dice press tool to be redesigned. The prosthetic hand of the Middle Age was present merely as a prop. Today, we have bionic hand prosthetic that give much better functionality, acceptable to more patient and are durable and comfortable. However, these prosthetic still have to overcome considerable hurdles in order to mimic or even improve upon the elastic hand, and they carry significant economic implication. Alright, here we can see that all design, the lubricant is designed to preserve humidity on the mold surface at the highest temperature. It is also intended to increase the formation of the film in the casting process. The area at which implant reach the skin that called stoma must be cleaned twice daily. Okay, for the new design, PLA is biodegradable and is produced from renewable energy source. As such, PLA generally result in even less wrapping and therefore does not enable a holster bed as well. PLA is biodegradable from renewable energy, does not cause poisonous smoke when it is melted. PLA is highly irregular when consumed accidentally, going to look super cheap to consider purchasing it. PLA also generally result in even less wrapping and therefore does not enable a heated bed as well. For the recommendation, the problem of designing, constructing and testing a prosthetic robotic arm hands is formidable in assistive robotics. It must enforce high dexterity, many degree of freedom, fast motion, large workspace and high precision, while complying with strict weight, power consumption, noise and appearance requirement. Relatively dexterous elbow, wrist and hand prosthetics are now commercially available that are increasingly sold and implant. Prosthetic control is then the issue of allowing the amputee to control this artifact fairly enough to master their dexterity to their base extent and natural enough to let the patient feel the prosthetic in a part of the body. Next, it is the training set must include in advance all possible source of chance in the input signal. Typical conditions such as sweating, relative skin, muscle movement, change in the musculature configuration due to body movement, arm stretching, scroll are essentially invisible. And last but not least, the potential need to learn new configuration as time passes. Example, conditions that are an essential part of an amputee life. For instance, as outside to grasping something on the ground, consider the very different upper line position and orientation while grasping object from shaft above one head.